kids!
All right, we're going to do a voltage problem this time. Determine the voltage at a point that is 2 meters from a positive 4 nanocoulomb charge and a positive 5 nanocoulomb charge. And then the second part is, hey, you know what, if I put an electron at this point, how much energy would be stored in the system? So if you wanted to do this, I would suggest you first want to draw it out. So it doesn't really say how far apart they are, so I have a 4 nanocoulomb charge here, and then I have a 5 nanocoulomb charge there, and let's say I just have some random point here where this distance is 2 meters, and this distance is also 2 meters, so that's the random point that I'm trying to figure what the voltage is, okay? Couple things you have to realize and have to understand. First, voltage like energy. This word could be, just so you guys know, it could be electric potential. Okay, remember electric potential and voltage mean exactly the same thing. Or if it asked, hey, what's the, it'd probably be electric potential. But anyway, or it could be potential difference, sometimes means voltage too. But you have to realize voltage or electric potential is a scalar, okay? That means that there's no direction to it, but it does mean positive and negatives are important, just like when we talked about work as a scalar. Positive work, you're adding energy. Negative work, you're taking energy away, okay? But if I was to do this, if you look at your formula sheet, you'd go, oh, okay, well, I know that my formula for voltage is this. Voltage equals K. Again, they have the 1 over 4 pi, but it's just K. Q over R. And then you just got to plug your stuff in. So really, if I want to know my voltage at this point, if I call this charge A and this charge B, then you know what? Okay, my voltage at this point would be the voltage from A plus the voltage from B equals my net voltage, if you want. And then it's just a matter of plugging your stuff in. So at A, I am going to have 9 times 10 to the 9th times 4 times 10 to the minus 9th, nanocoulomb times 10 to the minus 9th, over 2 plus 9 times 10 to the 9th times 5 times 10 to the minus 9th, over 2. And then if you work it out, I think I already worked it out. I think this was 18, and this was 22 point. This was 18 volts, and this was 22.5 volts. So that means my net is 40.5 volts. Okay, so boom, that's you're done. If you wanted to figure out how much energy would be stored if you put an electron there, just take this number and multiply it by the charge of an electron. Just remember this is true. So, all right, so I go negative 1.6 times 10 to the minus 19th times 40.5, and then you're going to get a number. Now, you'll get a negative number, and that's important. It just tells you, hey, you know what? Remember potential energy, it's like if I call this 0, I'm down here, up there, it just means I have negative potential energy, okay? But that would be that second part of the answer. Since I have you here, if the question was reversed or changed, so this was now negative, okay, which means this is negative. All that changes is now this is negative, which means that my answer would be, what, 4.5, negative 4.5 volts, okay, which means this would be negative 4.5 volts, which means now I'm going to get a positive potential energy. Okay. All right.
Bye, kids!